Hi, everybody. Welcome back. Today, we are going to be working on Notes 5.2, Part 2, where we're going to talk about this concept known as a reference angle. And so, reference angles are related to the angles that we've been drawing, especially when we start talking about trigonometry a little bit more and the trig values. So, let's get started here. When we're talking about a reference angle, and of course, always have your word wall handy in case you need to add a couple things to it. But when we are talking about a reference angle, it says a reference angle. Uh, Let theta be an angle in standard position. All right, so first of all, my regular angle, theta, so here it is. Look at that right there in quadrant number 2. There's my theta. Here's a theta in quadrant number 3. And then here's a theta in quadrant number 4. Okay, so there we go. So we have theta, nice and in red. So theta is an angle in standard position. Now, the reference angle for theta. We already know that a reference angle, or sorry, we're learning that a reference angle is an acute angle that they want me to call theta prime. And most importantly, it is formed. Look at that note right here. Formed by the terminal side of theta and the x-axis. Notice it doesn't mention the y-axis at all. The y-axis is something that we don't really care about too much for today. When we're talking about a reference angle, our concern will always be the x-axis. So a couple things I want to mention. They said, in order for me to have a reference angle, so let's zoom in a little bit more here. If I'm going to work with the concept of a reference angle, one, it says it needs to be acute, so it has to be less than 90 degrees. So there's the first concept we need to know about it. And here's the other one. And they don't really mention it, but it should be said. It's always positive. So even if you're working with negative angles and then they ask you about a reference angle, your reference angle should always be positive. So that's the biggest thing to note today. In your word wall, this is probably what you need to add into your word wall. It's very useful, especially the idea that it's always going to be a positive number. So this other one that I highlighted here, this line that I highlighted in green, it says it's formed by the terminal side of theta and by the x-axis. So here's what we have to think of. For that green part there that's highlighted, for the reference angle, and to save a little time, of course, I'm going to use my geometry angle symbol. So my reference angle, which they are calling theta with the little prime just to give it a new look, basically think of it this way. All right. It is the shortest distance or the shortest path, people like to say. You could pretend like you're walking along a circle here. It's the shortest distance back to the x-axis, which is what it says here. Remember, I want something that's less than 90 degrees. So that's why we're saying it's basically the shortest distance back to the x-axis. The big note to remember here is it's never the y-axis. We are not going to be using y-axis angle markers for this. Every angle marker that we see is always going to be related to the x-axis or the y-axis, never the y-axis, just the x-axis is the only one we're going to use. So here we go. Let's talk about reference angles. So when we look at our pictures have that theta prime already. So we're going to do one at a time. I'm just going to move this up. I want to zoom in a little bit more. I know there's other things written. It says that we're looking for angles between 90 and 360, but really we're going to look at one full turn here. All right, so a reference angle. When you have an angle that lands in quadrant number 2, the idea is we're basically standing right here. We're on the terminal side. And pretend that I'm just kind of walking along a track, right? A circular track. The question becomes, all right, well, what's the shortest distance back to the x-axis? Well, I technically have two options. To go back to the x-axis, I can either keep walking counterclockwise until I get to the x-axis here, or I could walk backwards again, go back this way. But if you notice, that angle that's already going to be more than 90. And the rule is we have to be less than 90 degrees. So that's why when I'm in quadrant number 2, I'll keep walking along the path, because this right here, that's our reference angle. It has to be less than 90. And so my reference, I'm just going to write ref angle, is this one right here. So we're looking for this little angle here. Remember, it's got to be less than 90. So then the question is, all right, well, how do you find it? Well, look, if I'm in quadrant number 2, think about the angles we just wrote. Theta, this would be the angle marker for theta. But as I'm walking along, yeah, this is 0. Remember, this is 90, but we're not going to work with that. This would be 180. So these are the two angles that I need to work with, because my reference angle is going to be between them. So the note says to find that reference angle in degrees or in radians, I'll highlight the degree, it's easier to understand it for now. It says you would go 180 and then take away whatever this angle is. Well, that makes sense. We learned that in geometry. If I know the entire angle is 180, I'll take off this red angle theta, and that should leave me with an angle less than 90. So if you notice, all we have to do is just do a little bit of subtraction. That's all we need. In fact, let's make that a little note here. So this is our rule on how to find a reference angle. For the reference angle, to find the reference angle, all we have to do is subtract. Now, some people will say, well, how do I know what order to subtract in? Well, remember, we already said the answer will always be positive. So we would take the bigger number and subtract the smallest number. 180 would definitely be bigger than whatever this angle is. So it says 180, take away whatever angle you have. Now, we also have one in quadrant number 3. Now, when I'm in quadrant number 3, it does change a little bit. Notice, I'm standing right here in quadrant number 3. But I want to go back to the x-axis. Now, I could keep going this way, but notice that path is too long. We want the shortest distance back. So actually, I'll backtrack on this one. But if I'm looking at my angle markers, this is the theta angle marker. I'm going back to this one, which was 180 to begin with. Well, then these are the two numbers that, just like last time, I'm going to subtract. But notice the difference. In quadrant number 2, yes, we're talking about subtraction. Look at which angle we went with first. We went with theta first because it is bigger than 180. Again, your answer needs to be positive. But we have a little formula there. And then finally, we do have angles in quadrant number 4. Now, there is a quadrant that wasn't mentioned. We'll bring it up, though. In quadrant number 4, all right, so here's my angle theta, which means this is the angle marker for theta. But when I'm trying to think about a reference angle, I'm going from this line, and I'm going back to the x-axis. Now, again, that means I could go this way, not to the y. I would keep going, keep going, keep going. But that's already more than 90. That's why we know we have to go this way. This is my reference angle that I'm looking for. So I know theta's involved because that was the angle marker I drew. So that's why we have to know how to draw angles. But then I should also know that this would now be 360. Yes, it's 0, but 0, we passed that a long time ago. If I'm going around full circle, that would be the 360 marker. Then these are the two numbers I'm going to use. And just like last time, if I want to find a reference angle, all I have to do is subtract my numbers. And so there it is. And look, they went bigger number, 360, which would be definitely bigger than whatever theta I drew. Now, there is one quadrant that wasn't mentioned because we don't really need a rule for it, but we do have a spot for it. So just giving you a moment to catch up there first with any kind of highlighting or anything else that you needed to do. But just remember, we were subtracting. Here I went big number minus the little one. Big number minus the little one. It's always the same rule. Big number minus the little. So here's what I want to show you. What about if you have quadrant number 1, right? They showed us every other quadrant except quadrant 1. So I have space here. We'll put it right here. What happens when you have a reference angle in quadrant number 1? Well, look, We're going to write quadrant 1, quad 1 for short. Draw a little XY plane. So now the question is this. What if I were to draw an angle in standard position and it ended here in quadrant number 1? So there's my theta marker. But then they said, remember, a reference angle has to be less than 90. Well, this angle is less than 90. And to draw a reference angle, I have to go back to the x-axis. There's my theta prime. Well, if you notice, it's the exact same thing. In quadrant 1, it's the only time your angle matches your reference angle perfectly. So again, look, I would be using 0 if you want to think of it that way. So theta prime would be theta minus 0, which is just theta. So that's why they didn't put it in the note, because if you understand that a reference angle has to be less than 90, and anything in quadrant 1 is less than 90 anyways, then you don't need to do any math. Your reference angle is the angle you drew. Now, one thing to notice about these little rules, and again, it's in your word wall. So I'll show you right now with your word wall. See, here it is, reference angle. It has all of that multiplication, including quadrant 1. Look, it says they're equal to each other. But it tells you how to do each one. What you need to understand is, in order for me to find a reference angle, my angle needs to be within one turn. If it goes beyond 360, that's when coterminal angles kick in. And remember, for coterminal angles, all I have to do is add 360 or subtract 360 as many times as I can. So that's why we save this section as the last part, because we need the concept of coterminal and, of course, reference angles. They kind of go together. All right, so let me show you how it works. It says, find the reference angle for the given angle theta. All right, so they drew it for me, so that was kind of nice of them. They drew this problem for me. So it says, find the reference angle for the given angle theta. They said theta is 300 degrees. Well, they already drew it for me. There's my angle, but I'm going to put the angle marker right here. There's my 300. But now I need to find a reference angle. Well, they said the reference angle is the shortest distance back to the x-axis. What's already here for me? Remember, I'm right here at this line. So the shortest distance back to the x-axis is to keep going. So if this is 300, well, I'm going back to 360. So remember, for reference angles, you're either working with 180 or 360. That's really all you're working with. All right, well, I'm going to use this number, and I'm going to use this one. That's my angle marker, and that's the x-axis angle marker. So theta prime, right there. All I have to do, we said, is subtract. But the rule is big number first minus the small number. In case you forget, well, which one is which? Well, look, I'm in quadrant number 4. So it tells me in the word wall, it tells me here, go 360 minus theta. But look, big number, 360, small number, the 300. That's why I like to circle my angles. It reminds me of which two numbers I'm comparing anyways. And we finally find out that theta prime, that reference angle, is 60 degrees. And just like that, we're done. That's the little angle right here. 60 degrees and the 300 do have a connection, and it'll come up in the notes. But that's why we need to know how to find reference angles first. All right, so now here we go again. Let's try another one. All right, so I'm looking at this one. Theta is equal to negative 370. All right, let's draw it. So this one needs a drawing. Here comes my XY plane. Let's see, there's 0 to start it off. Now it is going in the negative direction. So there's negative 90, negative 180, negative 270. Look, you see, I got to keep going. Negative 360. All right, now negative 370, that means I've already gone full circle once. And if it's 370, I just have to go a little extra. All right, so there it is. There is my angle marker for 370. Now that was negative. All right, but we have a little bit of a problem here. See, I drew this negative 370, but we already know my reference angle needs to be positive. Well then, we should find the positive angle that ends right here, and no full circles, none of that. My job is to find this orange angle right here. I want a positive angle that ends here. Well, that's where coterminal. That's why we learned the concept of coterminal. I want to find what this orange one would be. So for coterminal, we said add or subtract 360. Well, look, it's negative 370. I'm trying to get a positive angle, not a negative. Well, then I'm going to add 360. It makes no sense to subtract and make my negative bigger and bigger and bigger. All right, so I do my subtraction and I get negative 10. Yeah, that still doesn't work. We're looking for positive angles, not negative ones. So I'm gonna now take that negative 10 and add 360 again. And just like that, look, here we go. 350 degrees. We finally have the positive angle. So instead of calling it 370, I'm going to work with 350. And because I'm in quadrant number 4, I'm going to do exactly what I did over here. Now, instead of calling it negative 360, I'm going to call it positive 360 because I don't have negatives anymore. I'm going to work with that number, and I'm going to work with this one. Again, coterminal. We want only positive angles. All right, so here it is. Theta prime. That's what I'm looking for. Theta prime. Right there, my reference angle. Remember, it can't be 350. That was too big. So then theta prime is equal to 360, bigger number first, minus 350. That's the smaller one. And so my reference angle is just a 10. And if you're wondering, well, didn't you get a 10 earlier? You could have just used that. Well, technically, it's not a positive. Remember, reference angle should always be positive. But if you can make a connection like that and understand it, then go for it. Save some time. All right, let's try this again. I know it says you try, but we're going to try 2 more. We're going to do 2 more together. Now, this one has already been drawn for you. It says negative 130. All right, well, they already drew it for me. There's negative 130. But remember, that doesn't help me. I want to know the positive angle that was supposed to be there instead. I want this green one. I want the coterminal that goes with it. So I'm going to go coterminal. And remember, in your work, you don't have to keep writing this. Just do the math. So I'm going to take that negative 130, and I'm going to add 360. And when I do 360 and I add 130, well, I get 230 degrees. And look, it's already positive. So instead of calling it negative 130, I'm going to call it positive 230 because of the math that we did here. Now I can talk reference angle. If this is 230, now remember, reference angle, I'm standing right here on this line. I got to go shortest distance back to the x-axis, never the y. We never use this. Well, then this is the shortest way back to the x-axis. I don't want to go this way. Look, that's too far. That's more than 90. We don't want that one. This is the one I want. That means when I was drawing the 230, I passed the I passed the 180 to get there. So I'm going to use 180 and the 230. And remember, it's in your word wall anyways. When you're in quadrant number 3, there it is, quadrant number 3, it says it's theta minus the 180. Once you know what quadrant you're in, you can use this part of the word wall to guide you. So theta prime is 230 minus the 180, the smaller number. Again, I like circling the 2 angles I'm going to work with. I don't want anything else to throw me off. And now I know that my reference angle is, and in this case, we're looking at 50 degrees. Now, how do I know I have it right? 1, it's positive. 2, it's less than 90, and that's what's important. All right, I'm going to do 1 more with you, and then you could do the other you try. We'll do number 9. That way you could do the you tries over here, number 8 and 10. All right, so negative 570. All right, let's draw it. Now we're going to keep track of all the negatives first. So let's see. 0, negative 90, negative 180, negative 270, negative 360. All right, you got to keep going. We haven't even gotten close to 570. Add another 90, negative 450. Add another 90, negative, all right, let's see, what's that? 540. All right, we're getting closer. And then over here, add another 90 again. So 540 plus 90, 630. All right, so negative 570 is right here, somewhere in here. There's the negative 570 for now. Yeah, but we don't like that number. Now, instead of drawing this one, right, because we did this, but you see it did too many circles, right? It did one full circle. We don't want that. I want to know this angle. That's the one I want to know first. And that's what coterminal means. I want to know a positive one that lands right here. So then look, all I have to do for coterminal is take the negative 570. I know I want to go positive, so I'm going to add 360. So 570 plus the 360 is still negative 210. Okay, I don't like that. I'm going to take that negative 210 and I'm going to add 360 again. I'm trying to get a positive one out of it. So when I do the math there, I get 150, and there it is. That's the one I want. Now, you could just do this first and then draw that angle. Remember, you're still going to land in the same spot. That's what coterminal means. So instead of using negative 570, I now know I'm going to call it 150. And if this is 150, then my reference angle is going to go to 180. Because when I'm in quadrant number 2, according to my word wall, these are the two numbers I should be using. Again, my word wall has that. My notes have that. These are my two numbers. So here we go. Theta prime, to get messy a little bit here. Theta prime is 180 because it's bigger, minus the 150 that is smaller. And just like that, we find out, and there it is. Look, reference angle. It's positive, check. It's less than 90, check. So everything worked out with it. All right, right now you're going to take a moment. You are going to try these two problems here, number 8 and number 10. And once you do those, we're going to give you about 10 minutes to work on the first part of your classwork for today. Don't forget your homework for today. It's also on BIM. So when you do it on paper, check your answers on BIM and submit there. But you should be able to do numbers 1 through 6 on today's classwork as soon as you try these two. All right, try it out, everybody.